purpose in this video is to take a look at finding regression equations in Google Sheets. So I've got some data already in here for the population of 2 animals, perhaps in a national park. I'm going to first highlight these 2 columns, and I can choose the Insert Chart button, or I could go to the Insert menu and find Insert Chart, and it by default chooses a good format, and it gave me a column chart under our chart editor. The first option under data is the type of chart, and we're going to choose scatter plot. So we need to scroll and find scatter plot. So it plots our XY coordinates, and then I'm going to go to customize in our chart editor. And I'm going to go down to series. We could do a lot of other formatting as well. You've learned that in other videos. I'm going to make my points larger here. And you can format them as you wish. You have lots of shapes here. I'll change them to diamonds so you see what that does. And you could change the color and so on. But now to find, it looks like this is a constantly increasing function, so I'm going to see what line would best fit that data. And all you need to remember to do that is to use this option trend line, and then if I scroll, you'll see the trend line formatting options. And notice what happened on the graph was it very quickly computed the best line to represent those data points. And I can take that line and I can change its color, I can change the thickness of that line, I can give it some labels, but what's more important to me here is the mathematics. When you study statistics later, you will learn about correlation coefficients and whether this is a very good representation of the discrete data points. But here I'll just tell you that if you click this option to show r squared, this is a correlation that tells me whether I have a good equation to represent those blue dots. And the closer it is to positive or -1, the better your correlation. So this line is a pretty good fit, and if I want to use it algebraically, the equation of that line I can find under this label pull down, and I just pick use equation, and it puts it right here next to our r squared value. So this is the algebra equation of the red line. So now I'm just going to drag this out of the way a bit here, and I'm going to close our editor, and I'm going to add a column here to use that formula. So this is the regression equation for bear. And this is a good chance to remind you of some formatting. So if I want to wrap that text, because it's pretty long, I want to fit it in the column heading, and I might make it right justified to match the rest of the chart. So now what I want to do is use this red equation, and it should come up with values that are close, not the same, but close to these numbers for the blue points. So our formula is right here. So I'm simply going to type that in. This times x means times the year. So in our formula bar, remember that formulas start with equal signs. So I'm going to put 7.134 times is always your asterisk, the shift 8 on your keyboard. And I want my x variable to be replaced with the year. And then our plus value is our y-intercept, if you've already studied that in algebra, 44.231. And when I hit equal, it gives me that formula. Now notice 51 is the red value, and that's a little bit higher than the actual blue point. And now let's use the relative addresses to copy that formula. So I grab that blue square and drag down. And notice that while they're not exactly the same, these are approximations. These are the red points that are fairly close to the blue points. So when the blue point is below the red line, then our column B would be smaller than our column D, and so on. All right, so why would we want to find this equation? Well, because it is our best predictor of what happens to the population later. So let's put year 2020 here. And if I want to see what our equation predicts for the population of brown bear, I will copy the formula down another cell. So I'll grab this blue square and drag down. And we're predicting 187 bear. Now, it's only a prediction. It might not stay the same, but it's the best predictor that we have mathematically. All right, I'm just going to drag this chart, which you could make look nicer. You could do formatting of the titles and so on. And now I'm going to try to do the same thing for wolves, and there's a few different ways to do this. You can select, because it's in the third column, you could do lots of different ways of editing. If I select all three of these, this is one method. You'll find others by experimenting. You want to tell it that you want to use column 3 or column C, but you don't care about column B. So for my data type, or my chart type rather, I want to go to scatter plot again. And notice here I have two different scatter plots at the same time, so I could have done these together. But now what I'm going to do here is simply say that I don't care about the, let me drag this over so you see our columns again. I don't care about column 2, the brown bear, so I'm just going to go here and I am going to remove it. All right, so now I just have the year and the wolves. So now, by the way, our chart title isn't very accurate. We might want to go to, when we customize, we might want to go right away to the chart title, and this time we're doing wolves versus year. So you might need to make some adjustments there. All right, but what I care about most is coming up with our equations. So again, I'm going to go to the series pull down, and again, you could choose different types of shapes here. I'll leave these as circles. But now notice in our chart here that there might be other types of formulas that work better than a straight line. So let's take a look. This time let's compare some of those trend lines. So I'm going to choose the trend line option. And again, just to see it differently, I'll change it to red and I'll make it a little darker. 4 points. And now let's use this. Remember, it defaults to the line of best fit. And I can't see everything here, so I'll drag my chart over. Let me click the show R squared, and it's 0.918 for our correlation, so that's quite good. It's a fairly close fit, but notice how far these points are from the line. So there might be a different type of curve. So let's try some of our other choices here. So instead of a linear prediction, I might try an exponential function, and it certainly got a lot better. Our correlation now is 0.978. I might try a polynomial, and you can try even more of these. This is what power, so this means a second power. Second degree is a quadratic equation, and notice that we have a very good correlation here, 0.993. And you could try the others. So if I tried logarithmic, not a good fit at all. So, and you'll study these more in your advanced mathematics classes. So I think that polynomial, that second power equation with a correlation of 0.993 is the one I want to keep. And if I go to label and choose use equation, then it will show me a second power equation. Remember that X represents the year. So now I'm going to close my editor, and I'm going to grab the chart and drag it where I can see that equation. And I'm going to do the same thing here. I'm going to now use that formula. So I'm going to use the regression equation or function for wolves. And again, if I want to wrap that so it looks like the rest of our chart, and if I want to justify it. And now in this cell, I want to enter this formula. So formulas, I'm in my formula bar, equal sign, 25.984 plus, and now I need a negative, so I'm going to put parentheses just to be sure I have a negative number, times is our asterisk, shift 8. X represents our year, so I'm going to click in this cell so that it can be copied to the others, and then plus, and then back to our formula, 1.801 times shift 8, our year, raised to, so caret symbol is the shift 6, raised to the second power. And if I've typed that correctly, it will be a close approximation, and I'm going to drag my chart again out of the way here, and I'm going to copy that formula down my columns, and it should now compare, not perfectly, but the trend should somewhat match column C. And notice for year 2020, which wasn't in our graph, we're now predicting that the population of wolves will be way up at 657 if this red curve continues. So that looks like it matches our curve. I might not want the regression formula to predict outside my points. I might say, well, I don't know what was happening in year 2005. So I might go to my year column and put 5 in. And notice I don't get predictions because I didn't copy my formula. So let's copy the formula down one more for each of these. And now I know what I think is the best prediction of the bear and wolf population here on the red line. So our red graph is the best fit. So we use it to predict these other values. And just get some more space here. I can copy my charts, remember, to another file if I want to put them in a Word document. So here, when I chose 5, I was putting a value inside, so inside the other point. So that is called interpolation. I'm going to copy that. I put that there so I wouldn't forget to say it. And when I was predicting what would happen in the year 2020, that was outside my measurements, so that's called extrapolation. So you use your regression formula to predict more data points, and that's all there is to it.